All right, in problem number 7, we have a rectangular steel bar with a 1¼ inch by 3 inch cross section that's being used as a diagonal tension member in a bridge truss. There's a lot of information right there. The diagonal member is 20 feet long, and its modulus of elasticity is 30 million psi. If the strain in the diagonal member is measured to be 0.0012 inches per inch, determine A, the axial stress, B, the tension force in the bar, and C, the elongation of the member. This one, I think it makes sense for us to begin with a sketch. Here we are going to be looking at a diagonal tension member with a rectangular cross section. So that's my crummy rectangular cross section. And then let's get the diagonal member drawn in. We should give dimensions that we know. So the thickness in the short direction is 1.25 inches. And the width in the wide direction is going to be 3 inches. And the length is going to be 20 feet. Now we have some tension force that is unknown. That's what we're trying to solve for. Also looking here for the elongation, so try and sketch that in. And there we have it. So let's look at what we know. We know our modulus of elasticity, 30 million psi. We know our width, 1¼ of an inch. We know our thickness, 3 inches. We know our length to be 20 feet, and I'll just get that into inches now. And we know our strain to be 0.0012 inches per inch. Now, things we don't know. We don't know our cross-sectional area, but that'll be quick to figure out. We don't know our stress. We don't know the tension force. And we don't know our elongation. Formulas. Let's see. We will need to use our strain formula to figure out our elongation. We'll need our stress formula to figure out our force. We'll need our area of a rectangle formula. And we'll need our modulus of elasticity formula. So working in order, let's find our stress first. We can find that using what we know. We know our strain and we know our modulus of elasticity, so we can just begin with the modulus of elasticity formula where stress over strain. And we can substitute those known values, 30 million psi and 0.0012 inches per inch. We multiply both sides by that number, and we come out to a stress of 36,000 psi. We wanted this rounded to the thousands place, and that's what we have. So that's A. Stress equals 36,000 pounds per square inch. You'll notice that I'm kind of going back and forth between using PSI and pounds per square inch for this unit. It doesn't really matter which one you use, especially for reporting your answer. The only place that you might find it useful to stick with pounds over square inches is in the math as you're working out what units are canceling. So next, we can use our known stress to find our unknown force. And for that, we'll need to get our area. So we'll take our 36,000 psi stress and set that equal to force divided by our area. And here I'm just going to substitute in the area of a rectangle formula, and we'll figure this out right here. So we multiply those two numbers together and multiply that area by our 36,000 psi, and our force comes out to 135,000 pounds. Let's check on our precision. We're asked to round to the 10,000s place here, so that's going to be 140,000 pounds. And finally, for C, we're looking for the elongation in that member, and so we'll use our strain formula here, where elongation over original length. And we'll plug in what we know about our strain, which is 0.0012 inches per inch. It's equal to our elongation divided by that 240-inch original length. Multiply both sides by 240, and our elongation comes out to about 0.29 inches. Rounded to the hundredths place.